Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're going to look at the area enclosed by tangent of x and 2 sine of x as we are between negative pi over 3 and positive pi over 3. So we're being asked to sketch the area and find the region enclosed by the curves. So let's start off by sketching. Instead of going straight into 2 sine of x, we'll just start off by reminding ourselves what sine of x looks like. If we have a basic grasp of that, it's not too hard to get to sine or 2 sine of x. Now, the key thing to remember is that our original graph is bounded between +1 and -1. And so we can observe that when we multiply our function by 2 on the outside, we're going to have the same exact picture. We're just going to have it be a little bit taller on top. We're going to go to +2, and on the bottom, we're going to go to -2. The second graph that we want to have on our lineup will be tangent of x. Tangent of x, the main key to remember is that middle one. So this one was y is equal to tangent of x. It has a couple of asymptotes here at negative pi over 2 and positive pi over 2. And it just repeats that same shape again and again and again. But because we have our graph that we want to create is going to be between negative pi over 3 and pi over 3, we don't need to know anything else. We know it's going to be stuck between those. All right, so let's slap these together. And we'll do that here. I'm going to give ourselves a little bit more space. We're going to have something like that. We are going to definitely want our curve to go on the back side because we know that this function is going to negative pi over 2 as well. We're going to have our slope up here and I do apologize, this is not the best graph, but it never has to be. It just has to be good enough. And here is the region that is enclosed. And that starts at negative pi over 3 and goes to positive pi over 3. You'll notice that because our trig functions have a nice pattern repetition to them, the area that we find right here is going to be the same as the area that we find right here. So why don't we just double from 0 to 3 our integral instead of having to do two separate integrals. So area, we are going to take twice from 0 to pi over 3. And we are going to take our top curve. So our top curve in this case is equal to 2 sine of x minus our bottom curve, which is tangent of x dx. So there is our nice curve as we have it set up. Now we are ready to integrate. All right, so that 2 is going to stay on the outside. Let's put some nice brackets in here. Always make sure that you're using your brackets when you're working with integrals and such like that because they are going to make or break you in this business. Our antiderivative for sine is a negative cosine. And we are subtracting the antiderivative tangent, which is the natural log of the absolute value, oops, of secant of x. And we are evaluating that from 0 to pi over 3. All right, so it doesn't look too bad yet. It's going to look a little bit worse, but we are going to make it look better in the end. It's not going to be too bad. It's just going to be a little bit of algebra, and that is why we want to go through this problem. All right, so let's start off by, I'm going to do this in a couple different steps. I'm going to first of all distribute this 2 throughout and rewrite it a little bit better, and then we will evaluate. So we have -4 cosine of x minus 2 natural log secant of x, and this is all from 0 to pi over 3. And this is going to give us now -4 cosine of pi over 3 minus 2 natural log secant of pi over 3. Okay, and that is the first chunk. And we are subtracting from that. And now we are going to pop in 0 everywhere. I don't know about you, but I don't like memorizing trig things very much. The good thing is when you're in calculus, you can usually get away with knowing very little trig. There's a few things that you should know, and this is sort of on the outer edge, is knowing cosine of pi over 3 is 1/2. You should definitely know that cosine of 0 is equal to 1, right? And if you don't want to memorize it, memorize the shape of the graph, right? There's cosine. We start at +1, so cosine of 0 is +1. The other thing to remember is that secant of x is 1 over cosine of x. So that tells us that secant of pi over 3 is going to be 1 over 1/2. In other words, the number 2. And secant of 0 is 1 over 1, which is still going to be just 1. All right, so we have our information that we can plug these numbers in. Now that we have our numbers in there, this is going to be -4 times 1/2 minus 2 natural log of 2. And I'm going to drop the absolute values because now we have a positive number in there. Minus 4 times 1 minus 2 natural log of 1. All right. Natural log of 1, the nice thing about that is we do know natural log of 1 is 0, so that part is just going to die out. We have -4 times 1/2 is a -2 minus 2 natural log of 2. And then we have a double negative here. We have a negative negative, so those are going to turn into positives once we multiply that out. So that's going to be a +4. And put our integers together. And our final solution for this is 2 minus 2 natural log of 2. So it's not too bad, but there is a little bit of trig involved that you should keep in mind and remember. There are some of these great things like knowing that secant is 1 over the cosine of x. Thank you for listening.